Okay, so welcome everyone to this new episode of EagleFly, the experimental debugger. And yeah, we are full of features and energy to start exploring and start doing this debugger. And for today, well, we already streamed a video before in the morning, and we just left off implementing. We were starting to implement the loop-like code editing, which in this case I already opened for a coder, and yeah, I guess we should finish it and see what happens. So let's go back to the place where we left off, which is I guess this one. So do you remember if it does compile? Yes, it does. So let me go back to MSDef so we can see what's going on. Okay, we got debug storage, and we want to create a file which name is review EagleFly data 0.efd which is fine. What happens, we got a handle, so that means that we should, in theory, have the file right there. There you go, we have it. And so now we create the map file with the handle that we got. And of course, Mr. Visual Studio won't let us see at all if we got it. Yeah, that sucks. That sucks. Alright. So what I would like to see Alright, we didn't get the handle. We have the handle to the data. We say, hey, give me the whole thing. And we have the name. So probably let's just get back to the grid file mapping. And I don't know why they changed the whole web page I mean, they were the last one was good, man. This sucks. I don't know. I mean, it feels totally weird. Uh, but well, anyway. So let's see. We have file mapping attributes, which I know. I mean, what does this symbol mean at all? You know, I mean, probably this is the problem, because we don't know what's that. I don't, I don't mean that. To be done. To be done, man. Are you serious? Okay, so okay, Mr. Visual Studio tells us, or Amazon, whatever, that the file mapping attributes has to be done. All right, and us as users, we should put as parameter what? I mean, for real, man. What's going on with this thing? So this seems like, yeah, we have a handle. I don't think that's the problem. Allow views to be mapped for read only, copy and write, or execute access. Page execute read. We have, I believe, page read write, which is basically the thing that we want to do with that file, with that memory mapping thing. Share, and then we have here, well, this is extra thing, and here we set 0 0 because oh yeah, because it doesn't have anything at all, you know. So we should copy the data first, and then we have a mapping thing, you know. So we should, I mean, I'm assuming that that's a problem. So probably what we should and well, just for be certain, because if we wanna do this, you know, I think that we should write onto there. I don't know if it's, I mean, just for testing, we can try to write this memory out onto the file itself. I guess, I mean, since it's all zeros, I don't know what's going on. I mean, I don't know what's gonna happen. It's gonna be zeros, but I feel at least it's gonna have a size, you know. Let me look at it. Yeah, because I remember that was a problem with the file mapping thing. It should have something in there. So if I say create file, I know, yeah. No, it was write file. So basically it's gonna be something similar to this. Probably, yeah. I mean, we only. So what we can do is to pass the handle instead, I guess. Well, but necessarily it has to be open, I guess. So we can open it. We can open it with EagleFly, I guess. And we say something like this. Yeah, open existing. Which in fact, now that I think about it, we can try to do what I did. we could try to do something where we create a file. I don't know if we want to do that specifically with WinTrade to write our file. I would assume, I mean, for example, for reading, you would assume that there is, you know. For writing, I think I want to keep it like this, just for consistency with this function, with the other function. So yeah, so we only open existing attribute normal. I don't know what this is. This is security attributes. Yeah, 0. And since it's already created, I just want to open it with I don't know, I guess. I mean, the only thing that I don't see, or this only means, or this, oh, okay, cool. The sharing options for each open handle remain in effect until the handle is closed, regardless of the process context. So yeah, we don't care too much about it. So we can do something like, I mean, we're gonna close it on the same part, you know. So I think that's good. Flash share, right? And we get the handle. You know, we can even pass handle here, but you know what I mean. It's like tempting, but you know, I'm gonna do it right this way. And instead of this, we do this. after a page is removed from the working sets of all processes that we're using, the page becomes a transition page. Transition pages remain cached in RAM until the page is either referenced again by some process or repurposed. Okay, whatever. So we were saying that we get this is something in the system updates a file pointer before write file returns. So we can probably return something like mm, mm, mm. Uh, it seems that we don't have a save truncate, which is fine because we can implement it. Oh no, yeah, we have truncate, run, run. This is the one that we want. So we're still there, okay? And let me put back my int x equals 5 so we can look at it. And also we should stop debugging. And yeah, alright, so what we did here was just basically copy the whole data out. Of course, this has nothing at all, you know, it's set to 0. So I don't know if it's gonna work, but we can test it, you know. Since we create it, then we write the whole data, you know. And let me also go back to write entire file, and yeah, if it was open existing, let me go back. I'm not used to this format thing. Right, entire file. Where does it is? Number of bytes to file. This is not. No, it's the create file, isn't it? This one. And is this one. So if what we said is open file, is not error file not found. Alright. So probably we could do well, yeah, no. Well, we can try, yeah. We can implement this in the future. Page write 00, yeah, we write it back, and yeah. So let's see what goes. Let's see what happens here. Alright, we have the storage. We create a file because it doesn't exist. Well, now that I think about it, well, now it should be there, you know. So we pass here, yeah. So it's 0, you know, it's 0. And we know that total storage size, you know, it's it's basically k meg 11 megs. No, wait a minute, it's 1 gig plus 15 megs. Well, that's kind of weird, but yeah, that's what it is. Okay. Yeah, we got a file handle, truncate u32 tutorial. Yeah, we have it. It's not gonna happen. And this is because probably, I don't know if we want to write files bigger than 1 gig or bigger than u32 that can be 4 gigs. I don't know. It's kind of intriguing me. Probably we could allow that. I don't know, I guess. But I mean the things, yeah, I mean specifically the things that we probably want to allow that for would be for files specifically, but not for data. It doesn't matter because right now it's just, I mean, everything is passing through the same process, you know, everything is working on through the same code that's writing entire files. So if we need it, if we want to add that functionality, we can just add it and start exploring how to control that stuff, you know. And yeah, so we got total storage size. It doesn't change at all, you know, it's the same as this one. Oh, oh yeah, it's cool. All right, I think I should probably name it different, but this is, I write it, I don't know what happens. It's still 0, what I should assume. And the why is it already pointing to somewhere? Is that correct? Well, it probably was garbage, I guess. So yeah, yeah, our write didn't work, and also our create file mapping also didn't work. So yeah, so we got our window, everything's cool, but we haven't implemented, we haven't succeeded on having the file mapping object, which it makes sense because, well, we didn't write anything at all, isn't it? Or there's no data in it, you know. So what can we do? Let's try something different. What if we write a byte? That will have something in file, I guess. I want this to be write file and this write file, you know. And so yeah, we got the memory. We don't have a file mapping. We can look a little bit more into it. Let me think. What can I do? I guess I can do some kind of copy file, I guess. But that would be filled with garbage, I know. Well, let me just first, before going another route, let me see what this comes out to be, because it's a boolean, so we should have this to be possible, you know what I mean? Because yeah, what's going on here? To debug write file. So this seems to be a boolean 32. But I say it was a pointer. Oh, I see. typo. Alright, so let's see what's going on here, because now we can test for if we even write something, and yeah, we didn't write something. So yeah, that didn't work. So the thing that they did here for the mapping thing, they create this new great. Okay, they do this, they have the handle, file attribute temporary, and then when they create a file mapping, they copy the handle object to the HTML file, the handle, the file, the read writes, the norm, and they have an address there. So what if we try to do that thing, What if we say that we could, let me see. Well, let's forget about this for a moment. Don't care too much that for now, and we want to say that we want to map basically the whole size, and if we do that in that way, we have the maximum size Okay, so the low order door and the high order door of the maximum size is file mapping object. So it's gonna be two doors. So what we have to do, the other is a high, so this is correct, I guess. This is gonna be the first and the second, and that's all. You know what I mean? So what about that, So what if I do that? Okay, we have a size, We have a name, we have anything. Alright, we got a handle. Perfect. And yeah, we didn't need to write anything at all. We just say, hey man, this is the size of this, which in this case, I don't know if how can I say it? I mean, we know that that's the size of the file or the thing that we want to represent into the file, which, I mean, since we know that it's not dynamic, I mean, in the sense that we are not going to be moving, that sets us for success for preventing us on doing some kind of more fancy stuff, I mean, for now, I guess, I mean, if we have a size of a handle, and probably the size of a handle, yeah, because the view has to be inside the handle for the thing, So if we created a file, oh, for example, look at this. If an application specifies the size for the file mapping only, decided that the size of the actual name file on this, and if the page protection allows write access, the fprotect parameter specifies the page read write blah blah blah, then the file on this is increased to match the specified size of the file mapping object. So what we will assume is that now we have, there you go, we have this size there. Oh, awesome. So now we have basically done that, we have basically have the main map file to the size that we wanted. And awesome. Okay, so let's go and map the viewer file. So that means we don't need this. Alright, so we can even execute code with a file map with a MMF. That sounds a little bit crazy, but it's possible. Does that mean that it actually executes it? on the fly, or what's going on here? Because it's basically like it's gonna read the executable image into the file, into the address of the process, just as if, like if I mean basically like a dealer or something, you know, that it it's getting inserted, and it apparently runs. But man, that's crazy. So I think that we want all access. Whoa, where does this end? You know, because I think this, man, this is totally busted. I mean, I don't know where, because this doesn't make sense to be, because I mean it should be just this. This is for file map access, and this is for the file map copy. Or probably can be this one. So they are equivalent. Okay. So yeah. We probably also want to get the granularity of the system. So I would guess that the granularity means for the page size. Or no, sorry, should be allocation granularity. Processor revision. It can be x64, AMD or Intel, ARM 64, Intel Titanium, x86, unknown. The minimum application address and the maximum application address. Okay, that's useful. Intel 386, 486, Pentium, Anaya 64, say 664, non processor. The granularity for the starting address at which spiritual memory can be allocated. The starting address of the region to allocate. Rounded down to the nearest multiple of the allocation granularity. If the memory is already reserved and it's being committed, the address is rounded down. Okay, just because it's subcommitted. Okay, I got you. Probably we should take care of that. Oh, okay, I got you. So yeah, it's basically, I mean, it's gonna be mapped directly, you know. We have a file mapping object, you know, and that file mapping object has a size. So we're gonna with this we're gonna set an offset within that file mapping object, and that file mapping object has to take into consideration the granularity of the system, which I think we should do. Why now? Probably want to do it right here. for this case, we didn't care at all about where should it be allocated, so we have int to allocate memory, and this int to allocate memory has a null. So the alignment So yeah, probably we want to do something more specific for this, because I mean this is allocating with randomizing where we don't care, which is fine. That, I mean, most of the time we are not gonna care at all, but most of the time we enter a file. Well, in this case we don't care because it's gonna be 0 and 0, but you can take into consideration there. File offset low. Number of bytes to map. The number of bytes of a file mapping to map to the view. Okay, so we basically want to do this. So now we have already mapped it. I don't know what else do we need. Mapping a file makes a specified portion of a file visible in the address space of the calling process. For files that are larger than the address space, you can only map a small portion of the file data at one time. When the first view is complete, you can unmap it and map a new view. To obtain the size of a view, use the virtual query function. Multiple views of a file or a file mapping object as in its map file. Okay, that's important. A map view file is not guaranteed to be coherent with a file that has been accessed by the read file or write file function. So that sets us a little bit jankiness, because for a debugger, we don't know if the process is doing this kind of thing. So it's a thing. I think it's pretty janky to use some kind of this kind of data sharing, of this way of how you say, to view or to share the memory across processes. Do not store pointers in the memory map file. Store offsets from the base of the file mapping so that the mapping can be used at any address. Alright, so now that we have the address, we can start to use it on the calls to this thing, which I guess since we were passing up a start recording, we can say something like we're passing the win phrase to say in the memory. We probably don't need the memory at all, we just need the paste address for that. So I would say something like we have this pointer map view, and probably we want let's see, yeah, we want this, and not that. Well, I don't know if we were using that for something else, but we can test maybe one. And then I want to have like that, and let's see, well, I guess there you go. So we can do something like reduce, well, this can be called if we close it, we probably want to close it somewhere where we want to do that. For now, I don't think we care. Oh, we can have some debug data file, debug and map to map debug data file. How did I call it this? It was EFD, EagleFly data. Okay, debug EFD, sounds good for me. And this is the total memory size, total memory size, good. Allocated, I guess. Yeah, and this can be the mmap debug EFD view. EagleFly data view, EagleFly data map. Something like that. Domain access, something like that. And and this can be what's going on? we wanted to do that, or probably we wanted to do something like this. And we have the debug memory, the transistor size. This is gonna be Win32 state, total memory size, total memory size, total memory size, Win32 state, Win32 state, total memory size, and this is like that. Win32 read entire file. We got the pointers, then we have the data file handle. This is gonna be the Win32 state. Where's the save chunk? Oh yeah. This is the file handle. Debug data file handle. And I don't know if we want the memory index one or do you want truncated. I think this is okay because yeah, load the map and handle. What's going on here? Oh no. I got it wrong. I got it wrong. And this is Win32 state EFD map memory mm. Debug data file handle. We don't have that, so this is a handle. So I think we should close the handle after all this, you know. Close handle, the data file handle, and also we have that, and then also we want to have this right here. And this is the view, and this is just like this, and this is like the domain size, and this is Win32 the EFD map, EFD map. Alright, so let's see what's going on here, you know. And well, also let's just start by copying this, going back in here, and let's just start to get the data out. Let's ready to start recording. So if we want to start recording, what we want to do is to copy basically we want to copy the file we want to copy the data, can be oh let me think about this for a moment. We're gonna have we have the view, so we can say something like whatever the state of the data that we have, and of course it's gonna be we have the EFD view, which is a raw pointer, and I don't know if because basically for the practical reasons that we get, this EFD view points to the same well, no I'm sorry, no yeah so yeah they are different totally. So we have what we could say that we have the pointer to the memory where we are allocating. This is this book storage, and we want to basically copy this memory block. It's like if how can I say this, like memory block data block or block, I guess, and we have that block, and this is the FD view. So this view, it's a pointer that's in the address, and it's pointing to the file, and this file we have set ourselves with this fancy way of like mapping, where what we can do is to be like copying the data. So we basically want to move to copy the whole data. It's like a main copy, some main copy, something like that. I don't know, copy memory. I don't know if that's it, but let me see. Alright, yeah, it exists. So yeah, this is exactly what we need to do. We want to copy from the desk to the source.
this function is defined as the rotate long copy memory function from information series base memory. If the source and destination blocks overlap, the results are undefined. Actually, it's kind of crazy, because it's we how can I say, and probably this is a problem that we can encounter, but I don't know. It's that, I mean, if you think about it, we have just 2 GB of space, of addressable space for the process, but we have allocated 1.1 GB of and 50 megs of memory, and we have a nemmap file that also points, and it's addressable for what could be the same quantity. So we will have a total addressable thing allocation of more than 2 GB. It will be 2 GB and 100 megs, and those 100 megs will be out of place. And even, I mean, probably we have less because we have the boundaries for the process. So yeah, I don't know what's gonna happen. It's gonna go bananas. Probably we need to change the allocation size, I guess. I have no idea. For now, let's try it. Let's see what happens. Let's see. I mean, probably it's not. They are not gonna be overlapped at the time, but since it's not view file, it's gonna try to look for a place where you can put the pointer, and it's addressable from the same space. It's gonna be crazy. Yeah, because here we say total star size 332, and that's the size, and we set it to be that size. And indeed, I would really check if this could do it. Let's see. Well, let's try to do it. I don't know. Why not? So yeah, we have to copy the memory, but for a second I wanna go back into this. And so I compile. Alright, yeah, we got an empty a valid view, which, yeah, it's gonna be crazy. Well, don't worry, I'm not gonna worry too much about that right now, but we will see. For now, let's finish this so we can see what's going on. So yeah, we're gonna copy that thing with this copy function. The first parameter destination must be large enough to hold length bytes of source. Otherwise, a buffer overrun may occur. This may lead to a denial of service attack against the application if an access violation occurs. Or in the worst case, allow an attacker to inject executable code into your process. we can use intrinsic, which I don't think we have thought about him. Well, these are not intrinsics, but I thought they were. But these are not. These are. These are. Yes, they need memory.h and that thing. And this needs just kernel and Windows. Yeah. Alright, so let me copy this. Oh my god. Let me copy this. And yeah, we probably want the tests, you know, want the test. Want the test. Oh, I was thinking of memory block. Yeah, okay, whatever. And the source and the length. So block data, block size, yeah, and we kind of probably have, well, I can say something like this, and we can it's gonna be first, since we're recording, we wanna copy from the block. This can be also the debug block, I guess, so that we know that we're copying from there. And we're copying to the EFD. You know what I mean? Yeah. Yeah. There you go. And well, that's gonna copy it. And what else should we want to do? Well, if we're gonna start recording, we will say something like is recording through, and we wanna say something like this is just for the data, but this is a playground, I guess. Let me start to doing this for now, and if we want to do that later, we can do it. So let's see, Win32 stay. I can do something like if Win32 stay is recording, Win32 stay is recording, copy memory, and if we can assert that Win32 state is recording, and it can be an assertion or an if. Let me think about that. We should check about that. I don't think. Well, yeah, why not? And when we end the recording, we for the data we don't want to do something specifically.
Probably for the input, I guess. And for start playing, start loop. In 32 and recording. Well, we're gonna do that. Well, forget about the loop. Forget about the loop. So for playing, what we want is to copy back now for in fact we can do this, you know. Which I like it. And then we can try to this would be to here, from here to here, and we can do that. Into this day recording fast. Well, it's not necessary. Well, you know, something like this is better. And here's where we can do assert that we introduced if introduce the is playing loop is playing go through and basically this is gonna be here. Loop is playing. Loop is playing loop. No, loop is playing is better. Yep. Well, since I already set it to 0, I think it should be like this. Okay. Mm-hmm. Let me see. Well, we can do something like this. I think it's the other way around, isn't it? Let me see. Oh no, yes, that's the way. Alright. Alright. And so basically another thing that we should check about is right here. Which I know you should do it right here or right here. Loop is playing. So I guess Let me think about this for a moment. So yeah, this should have the debug memory block, yeah, and alright. So let's see what we have implemented. We wrote a bunch of code, so we would like to see if this is at least working. Truncated 64, we got the size, we create the memory block, the debug storage. In fact, let me copy this here. There we go. We load the DLL. Alright, so let's do this. So I believe it's, what is it, Control L. There you go. Even for to loop is playing, if not recording, we will start recording. If introduce stays recording, equal to true. If the data, we're gonna copy the data from here to here, and you see, I mean, this is this data. I just want to see the addresses, because I don't know how far they are from each other. And so it's like about 1, 2, 3, 4, 5. Well, in fact, you know what we can do. You know what I mean? So this is, oh yeah, perfect. So it's a location thing that we made. So just 3, 3. I mean, it's not necessarily the same quantity, but 3, 3, 3, and this should be equal to the debug black debug memorable to this. And yes, it is debug memorable. So actually they are that's funny. Debug block. You see, they are the same. So that means they are contiguous, or at least that's how the NT virtual memory manager decided to allocate them, because we didn't tell it to allocate it in a certain space, which is fine. That's good. So first is the first allocation that is for the debug memory block, and the next address space segment is for the EFDB block for the data. So we're gonna copy from the source as this to the EFDB block data. Okay, that took a while, and I will continue. Alright, so if I press shift again and say why is not entering. Okay, what's going on? We are still recording. Yes, it's down. Oh, we haven't removed this. What's going on with this? So what I wanna, how could I test this more reliably? Because in the first round, we enter. Oh, but now we are not. Does that mean we are not resetting the data or something? Let's see once again. Nope. It seems that we are not entering. So how did we enter the first time? What? Oh my god. Oh my god. Let me test against the was press. Let me isolate each one. So let me see if we enter there. Yes, we enter. We enter again. It's kind of funny because it doesn't, it's not so responsive as I was expecting. Now I want to see so should there be a problem with the control keys there? Now let's test against the control keys table. So yeah, the control key is not, oh sorry, yes it does. and this is more responsive than the other. So probably we have a bug on the wasp breast, because that's the one that's not super responsive. Okay, so let me go back to do this the other way. And test it again. It enters. It doesn't enters. It enters. I'll wait for a moment. It doesn't enter. It enters. It doesn't enter. It enters. And there's no control key flags. So are we just processing once per frame, or just one input? Which, I mean, probably it's because of this all nonsense that we have here. For multiple keyboards. Because the thing that I assume is that it should do this for it's in a while loop, isn't it? And this is the case of the M input. So is it because we are processing this for now? I mean, if we don't, you know, something like this, and we have just that, and we can get rid of this, I guess, but we have the dispatch messaging. And also I would like to check the okay, there's the input PKL. Continue, not entering. So what does the was press does?
Okay, so basically it does a comparison. So what I would like to do is, instead of this, let me go and open file, platform, and I would like to test this call. Where is it? This one. And I would like to check if this ever gets hit. There you go. Once we have the transition count as 1. That makes sense. The button and the down, it's true. Here we have a transition count of 0. A button and a down. Button and down equal 1. Which we can. Are you serious? Is it still there? So we have something busted. Is it because of the message? The same thing that I was telling you, but the busted of inputs. Let me see. Let me go to Win32. Yeah, we just reset the button and the down, the transition, sorry, not the button. I don't think this is a problem. Yeah, because this is kind of janky, because every time we reset, we will have I mean, it will have this kind of jankiness where we like kind of erase everything and we expect it to be reconfigured, rewritten every frame, which, I mean, because if we do this and we go to process keyboard or something like that, yeah, let me go to the definition, and this is gonna tell me, oh, it's different. Yeah, we have a transition, even though we don't have, because probably we are pressing and we shouldn't change the transition, probably we're pressing but we haven't changed the transition. We don't want that. That wouldn't mean anything for us. So yeah, this is not the problem. It would make us a little bit more janky than we ever do. So the reason that we didn't set it up right there is because we were debugging, which in this case, I guess we probably want to, I mean, we lost, but no, now that I think about it, I mean, if we stop the breakpoint, the message queue will be there. I mean, there should appear that we go out, So I mean, if I compile, well, let me go back, compile, and you know, if I'm gonna go there and I wanna go, where is it? Let me go to the processing of input. Well, more. Well, I'm gonna put one there, and I'm gonna put one here because this is just a switch, and we always process it. Doesn't matter what happens, you know. So we're gonna enter, and there you go. We press it. We have it's down, true. We go there. We have it there. It should be false. We enter, and we update transition, and the button the down comes to be down, and then we didn't process that, so that means that message won't get it probably, well, I don't think we saw true. And the button ended down, so yeah, we never entered back to that. So what I like to see is that instead of checking for that, is that I wanna we have to, this is basically the same, you know, with a mouse key. So yeah, we probably want to merge that, I don't know. But yeah, I would like to test more of if it's down, now it's down, go 5. Alright, so go out of this, you know, and just for be certain, I wanna, oh, I put it in the wrong place, but yeah, I wanna do this so that I correctly process that. Yeah, so yeah, it's because so that tells me that if I mean, if we are not on the loop, if we're not processing it, I mean, button and then down is true, and it's gonna be false now, you know. And the transition count is gonna be okay, so it's in the same loop. We haven't reset it. That's good. That means that it was so fast that the processing messages happens in the same frame. And we reset the button and the down to be false. Whatever, I don't care. So yeah, it makes sense because it was not pressed. I'll continue. Let me go here. There you go. Oh, I see. So that's the problem. Well, if I set the breakpoint, of course. And the reason is that it's gonna reset it on the second call, and then it's gonna put it back on the second call. So yeah, that kind of sucks, you know. But if I think correctly, the reason is because the dispatcher is already set it, or probably the message queue didn't return it for the process, because I don't know what's going on. Because how can I say? I mean, probably at this moment that message is already dispatched, so we don't have it anymore in the message queue, and we cannot transition to that state, and that's just because of the breakpoint that we set. So we probably want to control that also. I For correct debugging and that stuff. My question would be, if we still be using the Windows messages, would this happen also, or it will handle it a little bit more appropriately? Because we can. I mean, because probably that functionality, we don't want that functionality. I mean, it was just a test for uh, the wrong input. Probably we can remove that if we find that probably it's not exactly what we want, because it's not such a priority for us to have multiple keyword processing. It was just a test that we made so that we could see if we could handle that, but it's not totally necessary. So that means that probably, I mean, if I go here, huh? Oh, okay, so let me remember what those. But we don't care about that. So we probably want to do something better. We enter, and if we go input and keyboard, So the button is kind of janky the way debugging this, because uh, the message call doesn't get updated in that things. It's crazy. So yeah, I mean, it would be like what's okay, what about what's the key? The key is L, and it's down. Now it's not down. So yeah, well, at least we saw that we could try to find that thing. But yeah, we probably want to rearrange this input processing thing, because it seems not to be working at all, and it seems not to be the was pressed thing. Let's try something simpler, not a combination, but just the was pressed. What about that? mm, okay, we did enter. We know that we make the copy. That happens. Continue. That craziness happens again. In 32 and recording. Alright. So what about a recording? We are recording. We finish recording. We set the data, and loop is playing. And now we copy the memory back from the data.
to place. Alright. Okay, so now we're recording. Oh, it's something that we forgot to do. Well, since it's just a copy, it doesn't matter. If we start to do the input stuff looping, we could try to do something crazier here. But yeah, I think we first want to adjust the input stuff. Let me see what we can try to do with this so we can test it. Let me see. Since what I could try to do is to, instead of using this as the WinFate2 memory block, I can do something like this. And instead of this, it's gonna be well, I think that I could try to do something a little bit crazy, I guess. You know, let me go to EagleFly, and I would try to do something here with this thing, you know, for example, instead of to try to, where's the call for this? Here you go, and we want the debug memory. So basically we want the memory, debug storage, and I don't know what I wanna do with this. So I wanna say I wanna say something like this, you know. I wanna say we probably want to do something a little bit prettier, but you know, I want to say that this is gonna be pretty janky, you know, but uh, or even we can do something simpler, you know. Red max x equals red min x plus some size, you know,
size, 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 size. And well, we don't want to do it this way. Because it's gonna happen in the same frame, but we want to do it across frames, you know. So it's a little bit tricky. So it would be something more like rect, you know, it's more something like this. And probably it's more like this. This is pretty janky, I know, but don't do this at home, please. This is just a test. Okay, so it's more like you know what I mean? Well, in fact, it can be enough 82, I guess. So reference is gonna be if something more like that. Okay, so let's see what this does. Okay, so it's all bananas as I expect it to be. Okay. Oh, okay, that was totally stupid. Uh, 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 um, I'm gonna do this. Man, that was that was ridiculous. I was overrunning the buffer basically. All right. So now it's 1. Now it's 2, 3, 4. Okay. All right. All right. Super crazy. But what I guess what we could do is try to test if the loop like code editing works. All right. I press L. I think it does. What can I tell you, man? What can I tell you? I mean, well, if I press L, alright. Alright, let me do it again because that was not so obvious for me. Alright, so this is running and it gets to a certain state. So we probably want to do something like there, we set the state, and there we copy. Alright. Okay, so that's perfect. I mean, just do it once because that's what we probably tell it just to do. Which is not a loop, of course. But man, it's just a starting point. Yeah, we want to do probably a loop there. But I think that's where we're going to do it in the next stream. Because today we have run out of time. But hey, we have some kind of not one loop like code editing, which is fine, I guess. And that's all because we just copy the memory once. That's all. Alright, so it seems to work actually. Yeah. So it always copies the data out. That's the same. Okay. So yeah, I think that's good for today. And if somebody has any questions, please post it on Twitch, and I'll be happy to answer them. And I would ask a question there, because I mean I've been searching for a Twitch bot. If any it's available, if somebody knows about Twitch, a good Twitch bot that I can use just for sending out messages about when the streaming is coming, and or for the schedule, or I don't know. Uh, or, yeah, I mean, probably I can test out the API, but I don't know if there's something there that I can use, and that you guys have tested and used before, that you would recommend me. That would be pretty nice, you know. But yeah, that's just a question. Well, but it doesn't seem to that anybody have any questions. So I guess that's all for today. So yeah, we made some loop-like coding, one loop-like coding today, and yeah. So this is how it goes. We are continuing this on the next stream. And if you like the stream, actually, you can follow us on YouTube and on Twitch, and on Twitter if you want. Actually, I'm gonna put I'm gonna try uh, to upload this all these to make more influence, or to have more exposition on Twitter, so that people can follow the stream if they feel like to. And yeah, all right. So thank you very much, and I'll see you all on the next stream.